Okay, hello guys. Today we are talking about the convergence sum to infinity. Okay, so let's move to the first part. So here you'll find that here we have a geometry progression that is 1/2, 1/4, and 1/8. Okay, so we have like the first term a is 1, right? And the ratio here is 0.5, means each term is smaller or a half than the first term or than the before term, right? Okay, that is it. And we can say right here, we can just try to write down all it into a square. Like here, first is 1, and then it's a half, 1/4, 1/8. Okay, so you can find every kind of here represented for a part of the area, right? Okay, so here you can just consider like it can be considered as a sum to infinity. So it's very similar to the square form. Like if you add it with 1/16 and 1/32, 1/64, right? So you find all the sum together is very close to the square's area, right? So already here, like here, we have sum to infinity formula. So we already said that the first nth term Sn is a times 1 minus r power n over 1 minus r, right? So well here, if r is smaller than 1, bigger than -1, or we can also say that r's modulus is smaller than 1, we can set here when n is approximately approaches to the unlimited, that the value here 1 minus r power of n approximately equals to 1, right? So Sn can be considered as a times 1 over 1 minus r, that is a over 1 minus r. So we can call this as a sum to infinity for the total series. Okay, so the sum of the infinity is a over 1 minus r. Okay, and here that is a working example. So for here you can find the first term a is 16, right? And the second term is 12. So we said here the ratio is 3/4. Okay, and we said the ratio is also the modulus is smaller than 1, right? And the sum to infinity, because it's from the formula a times 1 minus r power of n over 1 minus r. Okay, so if here n approximately equals to unlimited, the value becomes a over 1 minus r. So here, the first term is 16, right? So it's 16 over 1 minus 3/4. So the value here is for 64. So the sum to the infinity is 64, okay? And here is another example, like if the series is 2 plus 2.2 plus 2.42, and to add all the values here. So the problem is, if this has a sum to infinity, so we already said here the ratio equals to, for example, like 2.2 over 2 is 1.1, right? So we said sum to infinity only support the ratio that is smaller than 1, right? But here, ratio equals to 1.1. So it's out of the range. Okay, so we cannot say here it can obey the rule that the sum to infinity, right? Okay, so it doesn't have sum to infinity because the ratio's modulus is bigger than 1. Okay, so here is student exercise for you. So maybe you can first try it on yourself and to solve the problems, and you can pause the video and do yourself. And here there's a symbol. I will give you a hint. Like from 1 to unlimited, here there's a sum uh, symbols. So it means like 10 times a half, 1 minus 1 plus 10 times a half, 2 minus 1 plus dot 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 to 10 times n minus 1. Okay, this is it. So if you want to follow with me, you can keep on going. Okay, so let's move to the first problem that is for this equation, right? And we can set here that the first term is n minus 1, n equals to 1, that is 10, right? So we said a is 10, and the ratio here is a half, right? So each term is a half than the first the adjacent terms, right? So we can say the sum to infinity is a over 1 minus r, right? So it's 10 over 1 minus a half, that is 20, okay? That is the first problem. And for second problem, the ball is dropped from 10 meters and it rebounds back here, 10 meter, rebounds back for 2/3 for each hit. So first time it rebounds back for 20/3, right? And 20/3, and then rebound back for second time, third time, fourth time, right? So it's a find total distance travel until it stops. So we can say it's 10 plus, here is 2 times 20/3 plus 20/3 times 2/3, right? Plus, maybe for another is for, I guess, is 20/3 times 2/3 squared plus dot dot, right? It will rebound back for n times, but we don't know n what is it, right? Maybe n will approximately equals to the unlimited, okay? So for this, we can set just using the sum to infinity, that is 2 times the first term is a, that is 20 over 3, right? Ratio is 2 over 3. So the value here can be considered as a over 1 minus r. So it is 10 plus 2 times 20 over 3 over 1 minus r is 1 minus 2 over 3, okay? So the final value can be considered as 10 plus 40 is 50 meters, okay? So finally, you can find the total distance traveled is very close to 50, maybe 49, 49.1, 49.2, and finally it will approaches to 50, okay? So that's for this problem. Hope you can understand for all of this, okay? So see you next time. Bye.